Hello, everyone. My name is Marvin Quispe. I'm a GIS specialist with the NGO Conservación Amazónica in Lima, Peru. One moment. Okay, it's a pleasure to meet with you today and share with you our research proposal at SERVIR Amazonia for the TensorFlow chain. In simple terms, our research proposal focuses on the detection and analysis of change in the exploitation cycles of alluvial mining activities in the Peruvian Amazon. You may wonder what I mean by mining exploitation cycles. Well, basically, I mean to know or detect if there is currently sediment extraction to obtain gold. That is, if the activity is being developed, or simple what we observe is a deforested mining area that is currently abandoned. First, I will introduce you to the SERVIR Amazonia team for the Geo4Good and TensorFlow exchange. These are the names of the people who will be attending and their lines of interest. Here are also our interest and contact emails. In the group, we are Milagros Becerra, Paula Paz, Felipe C. Rierne, Stephanie Jimenez, and me, Marvin Quispe. To provide some context, I will explain the reasons why we decide to choose this research topic. The alluvial mining, in most cases informal or illegal, is one of the main causes of deforestation in the Peruvian Amazon. It is estimated that to date it has caused more than 100,000 hectares of primary forest loss in Peru, and all this loss of forest and environmental impacts of alluvial mining in the Peruvian Amazon can be observed from space. Currently, you can see the image. We can detect with the satellites the change in the land cover and land use due to mining activities. Seeing the need to detect these mining activities, SERVIR Amazonia and Conservación Amazónica create a RAMI tool, mining monitoring using synthetic aperture radar image from the Sentinel-1 platform. RAMI platform detects forest loss due to mining activities in the Peruvian Amazon. As you can see in the image, using the Sentinel-1 satellite and time series algorithm called Omnibus QTES, we can detect these new mining activities. Here is the link if you want to explore the website and platform RAMI. Many of these new activities that we are detected by RAMI become inactive after a period of time of months or even years of being in the operation, and destruction of sediments in mining areas leaves ponds that then will with water and become mining ponds. When mining is active, these mining ponds increase the concentration of suspended sediments, which is why these active mining ponds are yellow in color. The opposite occurs in areas where mining is inactive. Mining ponds are filled with phytoplankton, algae, and other species turning a green color. A large percentage of the areas deforested by mining are only exploited for a few months or 1 year and then abandoned. For this reason, we not only observed areas where active mining becomes inactive, but also the opposite are areas where mining has been inactive for many months or years and then becomes active again after some time. This can be seen in the two images shown here. Understanding and detecting deforestation from new mining activities, as well as the on-off cycles of the mining activities, would allow for efficient monitoring and controlling of these activities. To obtain the data that will allow you to train, validate, and test the model, we choose the region of Madre de Dios in Peru as the study area due to its high mining activity. We will use 3 Sentinel images, 1 per year for the period 2021 to 2023. And Sentinel-2 was selected for its spatial and spectral resolution and sustainability over time. This is our workflow. Our workflow will be the one we are showing on the screen. We will use QGIS and ArcGIS to digitize the input data. Then in Colab, using the Google Earth Engine API in Python, we will export the patches in TF record format to GCP, Google Cloud Platform. Then we will train the model using TensorFlow in Colab to finally store this data and use it. Something important to mention, we are looking forward to test the new Google Earth Engine functions to export patches in TF record format, get pixels and compute pixels, and also to be able to run the vertex model in the Google Earth Engine code editor. For the architecture of the model, we are still defining which architecture to use. We have previous experience using CNN unit for binary segmentation for detecting logging and forest roads. However, we would like to combine a multi-class unit with another time series analysis architecture such as LSTM, for example. We are currently in the stage of digitizing the polygons to train the model because we have no previous data on the subject, and we need to digitize label polygons to train, validate, and test the model. Since digitizing polygons to train the deep learning model is tedious, and we want to have a starting point to compare the deep learning model with. So we trained a random forest model with 75 trees in Google Earth Engine using 4 classes: active mining ponds, inactive mining ponds, forest, and bare ground. With only 150 training points for each class, we obtain good preliminary results. So far, we have only digitized about through 250 polygons, and we still need approx 1,800 polygons, at least 600 for each year analysis. And the scale at which we are digitizing is one in 1,000, and the bands are B2, B3, B4, B5, B6, etc. This is there are preliminary results applying a random forest model. You can see our classification results of the random forest model in the link, in the list shown on the screen. Here you can see how from 2021 to 2023 mining activity has increased by a large percentage, and mining areas that have been inactive for several years have been reactivated. For the next steps, we have to finish with the digitation of the model training data, define the architecture, we will use and validate the model results and create an application to visualize the results. That's all. Thank you.
Thank you so much, Marvin. Thank you so much to the Amazonia team. Really, really thorough presentation. I love the workflow. I feel like I got a good sense of sort of the challenge you guys are up against. I know we've got a ton of good questions that are going to be coming in. I've got a bunch as well. So I know we've got like 13 minutes. We can do just a little wrap up with 5 minutes at the end, but I'll just open it to anyone if anyone has questions right off the bat. Let's see, I'm monitoring the chat. So the first question I had, if you go back to that, the random forest baseline, what's your yellow and blue prediction that you've got there? Are those different like times, or are they just showing just the random forest prediction? I think it might be slide 13.
Hi, Tim. Yes, maybe we can share again the presentation. Yes, the idea of this new proposal, this is Milagros, by the way.
Hey, Milagros.
Yes, Tim, the idea of the slide that we share is, first of all, the SERVIR or the RAMI tool using Sentinel-1, right? And it's trying to define the deforestation caused by mining. But this new idea is understand how the evolution of the mining itself. For example, we have information of when is a mining active, that is a yellow one, or a barely yellow, yeah, and then we have an active mining pond, that is a green one, a light green. So we classified those characteristics or those classes, and that information let us know to identify how the progress of the mining have occurred in the comparison of 2 years, 2021 and 2023.
That's wonderful. Yeah, thanks for the background. I think I missed it just in the presentation, but that's very clear now. It seemed like Marvin had said that you guys are in like a big hunt right now to get all this vectorized mining data, right? You're trying to actually create this data set. I know other teams are probably in that hustle right now as well. Either you're pulling from past projects and have this data, or you're coming up with new ways to collect the requisite input. And I just wanted to put this out here, and maybe other folks have had experience with this as well, is maybe some tips or tricks on flipping or like data augmentation, something that you could maybe also try in addition to just collecting more points and doing the hard work of vectorizing the data. There's also maybe some strategies that folks could think about. You want to think about the geography and the distribution of things and whatnot, but I know other folks maybe have some thoughts on that of strategies for getting the right amount of data, the right quality of data. So I don't know if that's something you guys have explored either. And the one I'm thinking of in particular is the near real-time deforestation in Cambodia. I know that the team in Southeast Asia, at least in the earlier versions, had some data augmentation and some flipping, and I think even maybe like the focal centroid of a patch maybe be even shifted a little bit. So those could be maybe strategies that you guys just keep doing what you're doing, but then maybe we could also, when we meet, talk about, those are some good approaches for, increasing your total number of training patches without too much more effort.
Yes. Hi, team. I'm Paula.
Hey, Paula.
Thank you. Yes, we are talking about we need to talk about how can improve the model, but I think that data augmentation is a good way to try to have more data, because we are thinking of try to digitalize more points. But I think it's a good strategy. I think Marvin has experience with that, but I'm not sure. But with another objective. I think I'm not sure if with the illegal logging, but we can explore that. Thank you.
Yeah, it's not, doesn't mean it's going to fix the problem, but it might cut down a little bit of overhead, right? So, yeah, any other questions to the Amazonia team? Open to anybody on the line. Yeah, go ahead, Glory.
Hi, everyone. Hi, team.
Hey, Glory.
So thank you, Marvin, for the presentation. That was really great. And I really like the fact that you tried to detect mining. This is really a problem in most of the mining, like problem that researchers in mining countries are looking for. So are trying to solve, I mean. So I would like to know if the workflow that you have shared is open source, if there's resources that we need to have in order to run it or stuff like that. Can you tell us more about that, please?
Maybe I can. Well, hi, Glory. About your question, is it the methodology and open source? Right now, we have initial results that is displayed on Google Earth Engine applications that Marvin shared. Right now, we review other information. The methodology right now is not in a GitHub to replicate, but we are more than happy during the SERVIR exchange TensorFlow identify ways to share the methodology and share data sets to replicate that analysis in other environments as it's in Africa. But right now, we have initial results displayed on Google Earth Engine repository that we just shared.
All right, thank you. So can you let me know maybe if that use higher resources or it's just like basic resources on Google Earth Engine, or we need maybe CPU, GPU and stuff like that?
I think for create the data set has been working in QGIS to the line the polygons, and then those information has been kept in Google Earth Engine. I think that's the way we use it. And
Well, great. Well, maybe what we do is we also plan, because I know, Glory, you won't be able to come to the exchange, right? So maybe we could even do like a debrief back to the group with all the things we learned from the exchange and sort of the resources too, because we want to make sure that I know folks in West Africa are really interested in this topic especially. Okay, well, let's go over to Katie.
Just a quick question for, because I'm curious just to understand better. So I know, just wondering what the difference between kind of this round of data collection is and kind of the data that you've collected already or digitized for the RAMI project. Is it that because you're looking at like active versus inactive mining sites, you need to kind of distinguish both of those in your labeled data? Is that kind of what the difference is?
Hi, Katie. Yeah, as well, regarding how the way we label the data, it's not similar. Well, first of all, we've been thinking using the results that we have from RAMI, but I think the way we label that information is a bit downloaded, a full or a complementary information of Sentinel-2 from 2021 and 2023, and that information is from August of 2021. I think we digitalized that information of that month, and then digitalized information of 2023. And as Mari mentioned by the chat, the idea is to complementary the RAMI methodology using SAR. That is the idea, because as RAMI tried to classify deforestation caused by mining, but this methodology or this approach is to understand the evolution of mining itself.
I see. Okay. Thank you.
That's fantastic. Any other questions? Jacob, go ahead.
Not so much a question, but more of a comment. I think that definitely we're going to want to talk with the Amazonia team as the West Africa team, because there's a lot of interest in mining, in gold mining in Ghana and the rest of West Africa as well. That's what our focus will be on for our presentation. And I think it's really interesting how you're looking at this evolution of mining. It might help with looking at where you can focus remediation or restoration activities in dormant mines. So I think that's a really interesting direction to take the service. And we definitely want to pick your brains a bit about that and maybe replicate some of this work. So thanks again for sharing.
Yeah, Jacob, thank you so much for also kind of connecting. I think it would be really, maybe, you guys just tag up via email too ahead of time. I know in 2 weeks this will be discussed also with West Africa, but I can imagine the different pond sizes and the availability of data might be some challenges on like direct replication, but maybe you can kind of think about that already because I know it seems like it's such a major interest right now in West Africa. I know we've talked about it directly. But I could imagine both the Amazonia team and the West Africa team basically sitting at the same table at the exchange, right? Because you guys are kind of positioning to answer sort of very similar questions. So hopefully we can make that happen, maybe organically or if we can force it. Well, great. Go ahead, Jacob.
Oh no, I was just gonna say yeah, for sure. I think that's what we're really looking for out of the exchange.
Nice. Okay. Any other questions on the line? I see that Vanessa has volunteered herself to digitize ponds. What a noble effort. I know that's a ton of work.
Just let me know.
Yeah.
Happy to help.
I love it. Yeah. And if you guys are exploring the data collection and augmentation and things like that, feel free to just ping us. We've got, I think Biplov is showing a couple examples, but that's something that might be more useful for, expanding the geography as well. Well, we got 1 minute left. Any other questions?
Our team about the documentation, Marvin said that they try to rotate the patch. So
okay.
they rotated the data, but we can explore the flip or another one.
Thank you all. Fantastic presentations. I wish we had more time, but we'll all get more time at the exchange. So thank you, everyone, and have the rest of your day.